In the last lecture, we talked about confidence intervals for a proportion. In particular, we were interested in the proportion of voters who would support the CRC library building. We took a sample of 238 voters, and from that sample of just 238 voters, we were able to say that if we were able to ask all the voters, the proportion who would support the CRC library building would be somewhere between 0.513 and 0.639, or in terms of percents, somewhere between 51.3% and 63.9%. That's a confidence interval for a proportion. Today, we'll talk about confidence intervals for a mean. The procedure for constructing a confidence interval for a mean is similar to the four-step process that we used to find a confidence interval for a proportion in the last lecture. Step 1, compute the point estimate. Now in the last lecture, our point estimate was called p-hat, and p-hat stood for the proportion that you get from a sample. So we use p-hat because we're looking for a confidence interval for a proportion. Now if you're looking for a confidence interval for a mean, instead of p-hat, we'll be finding x bar. And x bar is a symbol for the mean that you get from the sample. Step 2, in the last lecture, in the proportion situation, step 2 involved drawing the normal distribution picture. For means though, instead of a normal distribution, we'll be using another distribution called a t-distribution. And that's what this picture at the top here represents. The solid line here is the normal distribution picture that we've been talking about for the last couple of lectures. So I'm going to call the normal distribution picture the z-distribution. For the proportion situation, we drew the z-distribution picture. Now, the dotted lines are the t-distributions. So notice that there are a family of t-distribution pictures. It's not just one picture, it's a family of distributions, one for each sample size. The dotted line at the bottom here represents a t-distribution for a small sample size. And notice that it's different by a lot from the normal distribution picture. And what this picture is showing is that as your sample size gets larger and larger, the t-distribution gets closer and closer to the z-distribution. So for step 2, instead of drawing a normal distribution picture, we'll be drawing a t-distribution picture, which looks very similar. The confidence level is still the area in the middle. But instead of finding z stars, because we're using a t-distribution, we're going to find t stars. And in our last lecture, to get the z stars, this was an area to z question. And what we entered into R was Q norm, left area. For t-distribution, to get the t star, we're going to be doing QT in R. And for QT, you have to enter a left area and something called, that I'm going to call a DF. And DF stands for degrees of freedom. And the degrees of freedom is 1 less than the sample size. So n, your sample size, minus 1. And n is our sample size. After you have your t star from step 2, you'll find your margin of error, which will be a different formula. Margin of error for a confidence interval for a mean is going to be t star s over square root of n. S here stands for the standard deviation. And the n, as we said before, is the sample size. Last step is to construct your confidence interval by taking your point estimate, x bar, from step 1, and then adding and subtracting the margin of error, e. You might be wondering why we can't use the z-distribution for the means. And here's kind of an explanation. The goal of confidence intervals is we want to take a sample, and then use that sample to help us estimate either the true mean or true proportion of the entire population. And so back when we were talking about the normal distribution, we saw these two boxes. And these two boxes tell us what mean we should use and what standard deviation we should use in the two situations, in the mean situation and in the proportion situation. Now look at the proportion situation. The mean and standard deviation for proportions are linked together. Okay? The mean is p, and the standard deviation also uses that p in this big square root formula. So once you know the mean, the standard deviation is already determined. Right? You have no freedom there. Which means when we use our sample to estimate in the proportion situation, we're really only estimating one thing, this p. Because once we know the p, the standard deviation is already determined by the big square root formula, which is different than the mean situation. The mean situation, the mean and standard deviation are not linked together like they are in the proportion situation. So our sample, when we take a sample for the means, our sample is estimating two things, the mean and also the standard deviation. And because we're estimating two things with our sample versus one thing, the z distribution is going to be no longer accurate for the means, which is why we need a new tool, the t distribution. The second page here is going to serve as our formula sheet for confidence intervals. Today we're going to mix together the proportions together with the means. For confidence intervals, the end result is either going to be a p hat plus or minus the margin of error for the proportion situation, or x bar plus or minus the margin of error for the mean situation. The first two formulas here are formulas for finding the margin of error. The first formula with the z star and the p hats, that's for the proportions. The second formula with the t star, that's for the mean. The next two formulas are formulas for finding the sample size. And in the real world, you would use these two formulas when you're planning out your research or your study, and you're trying to plan out how many people you need to include in your sample. So you would be looking for the sample size. The first one with the p hats, that's for proportions. The second one is for the means. Now, all of these formulas involve either a z star or a t star. And z stars and t stars have to do with either the normal distribution, the z distribution, or the t distribution. So I'm going to draw both of those distributions the same. The confidence level has to do with the area in the middle. And you're either looking for the two z stars or the two t stars that have that area in the middle. And in R, you can either be using Q norm or QT. Q norm if you're looking for z stars, and QT if you're looking for t stars. And then finally at the bottom here, this is something that we talked about in the last lecture, the effect of the sample size and the effect of the confidence level. So if you're using a larger sample size, so larger sample size means a larger n, and notice that in these two formulas, the n, we're dividing by n in both cases. So if you're using a larger sample size, you will be dividing by a larger number, and if you divide by a larger number, you'll end up with a smaller number for the margin of error. So larger sample size leads to a smaller error, and a smaller error means your interval will be narrower. If you're using a smaller sample size, you'll have the reverse effect. Confidence level has to do with this picture and the area in the middle. So if you're using a larger confidence level, the area in the middle will be larger. Larger area means these Z stars will be bigger, or these T stars will be bigger. And in our formula for margin of error, Z stars and T stars are being multiplied. So if you're multiplying by a bigger number, you're going to get a bigger number overall for the margin of error. So larger confidence level leads to a larger error, which means our intervals will be wider. Smaller confidence level, you'll get the reverse effect. Let's try some examples. Example 1. To study the rental market in a city, a housing official surveys a simple random sample of 43 renters and found out the mean rent paid was $940, with a standard deviation of $300. Part A, construct a 91% confidence interval for the mean rent in this city. The first thing we need to decide is whether this is a proportion or a mean type question. And I think it's pretty easy to tell because it says here, construct a 91% confidence interval for the mean. Okay, this is definitely going to be a mean question. So let's go through the 4-step process. The first step is to find a point estimate, which will be either be p hat or x bar. Because we're talking about means, we're looking for x bar. And x bar is the mean that you get from the sample. So what is the mean from the sample? They took a sample of 43 renters and found that the mean rent was $940. So the mean is $940. Step 2. Step 2 involves drawing either the normal distribution picture or the t-distribution picture. I draw both pictures the same way, so they look the same for me. The area in the middle is the confidence level. What's the confidence level here? 91% confidence. So 91%, always converted to a decimal. So 91% as a decimal is 0.91. Okay, so 0.91 is this area in the middle. And we're either looking for 2 Z stars or 2 T stars. Because we're talking about means, we're looking for the 2 T stars. Okay, this is an area to T question. Area to T. Area to T. We're looking for T star. We're going to be doing QT left area DF in R. So QT left area DF. What's the left area here? It's not 0.91. 0.91 is the area in the middle. So I want the unshaded left part here. So how do I find the unshaded left part? So I'm going to start by doing 1 minus 0.91. Okay, let me switch over to the calculator here. 1 minus 0.91 is 0.09. Okay, so when I do 1 minus, that should give me the unshaded part, which is the left and the right together. I just want the left. So we'll divide by 2. So 0.09 divided by 2. 0.045. Okay, that's the left unshaded part that I want. So that's going to be what I enter into QT. But remember, QT takes 2 things. It takes the left area and also the degrees of freedom. So degrees of freedom is 1 less than the sample size. So what is our sample size here? So sample size is how many people we're selecting. 43 renters, okay? So 1 less than 43 will be 42. So our degrees of freedom is 42. Okay, so we'll do QT 0.05 comma 42. .045 comma 42. Okay, this should give me the T stars. For my picture, I expect 2 T stars. So one of them is going to be negative 1.735, so round to 3 decimal places. Okay, that's going to be the one on the left. The one on the right is going to be the positive version. So positive 1.735. Okay, so that's our critical value T star. Step 2, or step 3. Step 3 is to find the margin of error. Okay, we're talking about means here. The margin of error is going to be T star S over square root of N. So T star, I have 2 T stars. I always use the positive one, so positive 1.735. Okay, S over square root of N. S is the standard deviation. So what's the standard deviation here? Standard deviation, 300. Over square root of N. So N is the sample size. Sample size is how many people we're picking here. 43 renters. Okay, so the sample size is 43. Enter this into a calculator, 1.735. Okay, times 300 on top, square root of 43. Okay, round to 3 decimal places. This is 79.376. Okay, and then finally, you'll take your point estimate from step 1 plus minus the margin of error from step 3. And then to get our final interval, subtract to get the low number and then add to get the high number. So I'll start by subtracting. 940 minus 79.376. Okay, our low number is 860.624. And our high number is going to be 940 plus 79.376. 1019.376. Okay, so what we're saying here is that we didn't ask every renter in this city, right? We only asked 43 renters, which is a really small number. What we're saying here is that if we were able to ask all the renters in this city, the true mean will be somewhere between 860.624 and 1019.376. Part B. So part B is writing the interpretation sentence. So I want you to write, this is the type of sentence I want you to write for all of these. So start off with we are. State your confidence level. So our confidence level here is 91% confidence. So we are 91% confident that, and I usually just copy this part here, confidence interval for the mean rent in this city. So we are 91% confident that the mean rent in this city is between, and then low number, high number. So because we're talking about means here, means we don't convert to percent. So unlike the last lecture, these were proportions. So proportions, we do convert to percents. So these are means, we don't convert. So it's just going to be between 860.624 and 1019.376. And then I usually write like what are these numbers? 860.624, 1019.376, what are those? We're talking about mean rent, right? So the rent is money, dollars. So these are dollars. We are 91% confident that the mean rent in this city is between 860.624 and $1,019.376. Now that we have the sentence, we can answer some questions. Part C. Based on the confidence interval, can you conclude that the mean rent in this city is less than 1,000? Okay, so all we know is that the true mean is somewhere between 860.624 and 1,019.376. So the question is really, are all the numbers in this confidence interval less than 1,000? No, right? Because 1019.376 is definitely not less than 1,000. This will be a no. Part D, if the sample size were 30 rather than 43, would the margin of error be larger, smaller than the result in part A? So this is a question of, if we change the sample size, what happens to the margin of error, or what happens to the width of the interval? So if the sample size were 30, so originally it was 43, so a sample size of 30 would mean a smaller sample size. Smaller sample size, larger error, wider interval. Okay, so smaller sample size would be a larger margin of error. If the confidence level were 87% rather than 91%, okay, so originally it was 91%. If we change it to 87%, 87% would mean a smaller confidence level. What happens? So 87 will be a smaller, so smaller confidence level, smaller error, narrower interval. The margin of error would be, we said, smaller. Example 2. The dean of students at a university wants to estimate the proportion of students who log into Facebook daily. She posed a simple random sample of 200 students, and 134 of them report that they log into Facebook daily. Part A, construct a confidence interval for the proportion of students who log into Facebook daily. First question we need to ask is this a proportion or a mean question? Pretty easy. It says construct an 86% confidence interval for the proportion. Definitely going to be a proportion question. Okay, let's go through the 4-step process. Step 1 is to find a point estimate. It's either going to be a p hat or an x bar. Because we're talking about proportions, we're looking for a p hat here. So for the p hat, you will have to do a calculation. So p hat stands for the proportion from the sample. So what proportion of the sample logs into Facebook? So we sampled 200 students, and 134 of them log into Facebook daily. So our proportion from the sample would be 134 out of the total number of people that we sampled, which was 200. Okay, so on a calculator, 134 over 200. Okay, round to 3 decimal places if you need to. On this one, we don't need to round, so 0.67. Step 2. Step 2 has to do with either the normal distribution picture or the t-distribution picture. Both pictures I draw the same way. And we're going to shade in the middle. And the area in the middle is the confidence level. What is the confidence level here? 86% confidence. Okay, so as a decimal, 86% is 0.86. So we're looking for either 2 z stars or 2 t stars. Because we're talking about proportions, we're looking for z stars. Okay, this is a area to z question. For an area to z stars, we're going to be doing q norm left area. Okay, so this one's going to be q norm. Okay, if you're looking for a t star, it'll be a qt. So left area. 0.86 is the area in the middle. What I want is this unshaded part on the left side. Okay, so first thing I'll do is do 1 minus 0.86. Okay, so whenever I do 1 minus, that should give me the area of the unshaded part. 1 minus 0.86. 0.14. Okay, that's the unshaded part, which is the left and the right together. I just want the left divided by 2. Okay, so 0.14 divided by 2. 0.07. Okay, that's the left unshaded part, which is what I need to plug into the Q norm. So 0.07. In our Q norm, 0.07. Okay, this should give me the Z stars. So negative 1.476. From my picture, I expect 2 Z stars. The negative one is the one on the left. The one on the right is going to be just the positive version. So positive 1.476. Step 3. Step 3 is to find the margin of error. Okay, make sure we're using the correct formula. We're in the proportion situation, so we should be using this first formula. So Z star big square root P hat 1 minus P hat over N. Okay, Z star. Z star, I have 2 Z stars, but I always use the positive one. So 1.476 positive. Big square root. Inside the square root, it's P hat 1 minus P hat. So P hat is from step 1, 0.67. 1 minus 0.67 over N. N is our sample size, so how many people did we ask total? Total, 200 students. Okay, let's enter this to the calculator. 1.476 square root. Click on the fraction button right after that so that the fraction is inside the square root. Up top, 0.67, parentheses 1 minus 0.67. On the bottom, 200. Okay, make sure the entire fraction is inside that square root. I get 0.049. Okay, that's our margin of error. Last step, point estimate, which is from step 1, 0.67, plus minus the margin of error, which is from step 3, 0.049. Okay, and then to find our interval, I want the low number and the high number. To get the low number, we'll subtract. So 0.67 minus 0.049, 0.621. To get the high number, add. So 0.67 plus 0.049. 0.719. Okay, and that's my confidence interval. What we're saying here is that we didn't ask every student, right? We only asked 200 students. But what we're saying here is that if we were able to ask every student, the true proportion will be somewhere between 0.621 and 0.719. Part B, the sentence. So this is the sentence I want you to write for all of these. We are. State your confidence level. Our confidence level here is 86% confidence. So we are 86% confident that, and usually I just copy what they say in the question, confidence interval for the proportion of students who log into Facebook daily. We are confident that the proportion of students who log into Facebook daily is between. Okay, so for proportions, I do want you to convert to percents. 0.621 as a percent will be 62.1%. and 0.719 as a percent will be 71.9%. Okay, so we are 86% confident that the proportion of students who log into Facebook daily is between 62.1% and 71.9%. Part C. Based on your confidence interval, can you conclude that more than 60% of students log into Facebook daily? So what we know from our confidence interval is that the true proportion is somewhere between 62.1% and 71.9%. So based on that, can you say that the percent is more than 60? Basically, it's asking, are all the numbers in our confidence interval more than 60? Yes, right? 62.1, more than 60. 71.9, more than 60, which means all numbers between are definitely going to be more than 60 also. This is going to be a yes. Part D. If the confidence level were 96% rather than 86%, would the margin of error be larger or smaller? Okay. Originally, we used the 86% confidence. If we used the 96%, that would represent a higher level of confidence or a larger confidence level. What happens? Larger confidence, larger error, or wider interval. So larger confidence would result in a margin of error that is larger. Part E, if the sample size were 300 rather than 200, would the margin of error be larger or smaller? So originally, our sample size was 200. Okay, if we use 300 instead, so that would represent a larger sample size, what happens? So larger sample size will result in a smaller error or a narrower interval. So larger sample size, the margin of error should be smaller. Example 3. A newspaper wants to predict the outcome of an election by estimating the proportion of voters who support the construction of a mall in Elk Grove. What sample size is needed if the newspaper wants the estimate to be within 3% with 97% confidence? Okay, notice that it's asking for what sample size. So we're looking for a sample size, which means we'll use one of these formulas for n. The question is, are we talking about proportions or are we talking about means? So if we look at this question again, the newspaper wants to predict the outcome of an election by estimating the proportion. So proportion. So we're looking for a sample size in the proportion situation, which means we'll be using this formula. P hat, 1 minus P hat, Z star over E squared. So let me recopy that. Z star over E squared. Okay, don't forget the square. All right, so let's talk about what we plug in for each letter. Let's start with the Z star. Z star has to do with the normal distribution picture, okay, which is always going to be shaded in the middle. The area in the middle is the confidence level. So what confidence level are we using here? 97% confidence. Okay, so that's going to be area in the middle. 97% as a decimal is 0.97. Okay, we're looking for Z stars. Okay, this is an area to Z question. To find Z star, we're going to be using Q norm in R. So Q norm, left area. What is the left area here? It's not 0.97. 0.97 is the area, the shaded area in the middle. Left area would mean the unshaded one on the left here. So to find the unshaded part on the left, I'm going to first do 1 minus. So 1 minus 0.97. is 0.03. Okay, so when you do 1 minus, you get the unshaded part, which is the left and the right together, but I just want the left. So if I just want the left, divided by 2. 0.03 divided by 2. 0.015. Okay, that gives me the left unshaded part, which is what I'm going to plug into R. So 0.015. Okay, so in R, Q norm, 0.015. Okay, this should give me a Z star. There's 2 Z stars. So one of them is going to be this negative 2.170. And then the other Z star on the right should be the positive version. So positive 2.170. That's going to go in for the Z star. Now what about the E and what about the P hat? Okay, E stands for margin of error. So what margin of error are we talking about here? So the key word you should look for is, it says here, the newspaper wants the estimate to be within 3%. Okay, the word within is telling you what error the newspaper wants. So they want the error to be within 3%. So 3% is the margin of error. Okay, that's going to go in for E, but remember, convert that to a decimal. And then finally, what do we plug in for P hat? So remember from the last lecture, P hat, if there's an estimate for P hat, you're going to use it. If there's not an estimate for P hat, you're going to use 0.50. Okay, so is there an estimate for the P hat? So P hat here is the proportion of voters who support the mall in Elk Grove. So does it tell you an estimate for the proportion of voters who support the mall? No. Right? 97% is the confidence level. Okay, that refers to area in the middle. 3%, that's the margin of error. And those are the only numbers I'm given. So I'm not given a estimate for P hat. So if you don't see an estimate for P hat, use 0.50. Okay, so we have everything we need. So we're going to use 0.50 for P hat, 1 minus 0.50. Z star, we said we're going to use 2.170. E is the margin of error, which is this 3%, but always convert to decimals. So 3% as a decimal would be, move 2 to the left, that would be 0.03, so 0.03. And then don't forget the square. Okay, so let me enter that into the calculator. So 0.50, 1 minus 0.50, 2.170 over 0.03, close parentheses, square it, don't forget the square, and I get 1308.028. Okay, this is a sample size. In other words, how many people we need to include in our study. So it doesn't make sense to have 0.028. The question now is, how do you round? And remember, we're always rounding up. So you're not going to round the regular way. You're always going to round up. Okay, so rounding up, this would be 1309. Example 4. A researcher wants to determine the mean number of hours per week the typical person watches television. How many people are needed to estimate the number of hours people watch television per week within 2 hours with 94% confidence? Results from a previous survey indicate that the number of hours of television watched per week has a standard deviation of 7.5 hours. Okay, so this one's asking how many people. In other words, it's asking for a sample size. So again, we'll be using one of these formulas for n. And the question is, are we talking about a proportion or are we talking about a mean? Researcher wants to determine the mean number of hours per week the typical person watches television. Mean. Okay, so this is definitely going to be a mean question. Which means we'll be using the sample size formula for a mean. So n equals in parentheses z star times s over e. And then don't forget the square. There's a square also. And you might be wondering, if this is a mean question, why aren't we using t star here? And the reason is we can't use t star because t star requires a left area and a df. And df is sample size minus 1, right? So we're trying to find a sample size, which means we don't have a sample size. If you don't have a sample size, you don't have a degrees of freedom, which means you can't use qt. So there's no way that we can use a t star there, which means the next best thing is to use a z star. Okay, so that's why even though it's a mean, we're using z star here. Okay, so what do we plug in for each of these letters? Z star is easy. So z star has to do with the normal distribution picture. So let's start with that. It's always going to be shaded in the middle. The shaded area in the middle is the confidence level. So what confidence level are we talking about here? 94% confidence. Okay, so that's going to be, as a decimal, 0.94. That's the area in the middle. And we're talking about z stars here, so we're looking for z star. Okay, this is the area to z. If I'm looking for z star, I should be using q norm. So q norm, left area. Okay, so q norm, left area. .94 is the shaded area in the middle. I want this left unshaded part. Okay, so I'm going to first do 1 minus to get the unshaded part. Okay, 1 minus 0.94. 0.06. Okay, so whenever I do 1 minus, that should give me the unshaded part, which is the left and the right together. I just want the left, so divide by 2. Okay, 0.06 divided by 2. 0.03. Okay, that's the left unshaded part, which is what I'm gonna plug into q norm. Okay, so in R, we're gonna do q norm 0.03. Okay, so this should give me the z stars. So z star, the one on the left is going to be this negative 1.881. Okay, the one on the right should be the positive version. So positive 1.881. Okay, that's going to go in for z star. But what about S? Okay, what does S stand for? S stands for the standard deviation. Standard deviation, 7.5. So 7.5 can go in for S. E. E stands for the margin of error. So what is the margin of error? So just like in example 3, look for the word within something. So this says that they want to estimate the number of hours people watch TV within 2 hours. Okay, so within 2 hours is telling me the error that they're looking for. So within 2. So this is going to be E, the margin of error. Okay, so I think we have everything now. So N equals Z star. I have 2 Z stars. I always use the positive one. So positive 1.881. times S, standard deviation. We said the standard deviation was 7.5. E on the bottom is the margin of error. Within 2, margin of error is 2. And then don't forget the square. Okay, so on a calculator, I'm going to go, how should I do this? Parentheses, fraction, up top 1.881 times 7.5, on the bottom 2, close parentheses, and then don't forget the square. And I get 49.755. We're not done. So we're talking about sample size. In other words, how many people are we going to include in our sample? It doesn't make sense to have 0.755 people. The question is, how do you round? You don't round the regular way. You always round up. Okay, so we're going to round up. This is going to get rounded up to 50. Example 5. Michael and Lisa are going to construct confidence intervals from the same simple random sample. Michael's confidence interval will have level 90% and Lisa's will have level 85%. Part A. Which confidence interval will have the larger margin of error, or would they both be the same? So they're using the same simple random sample, which means they're both going to use the same sample size. And really the only difference is Michael is going to use a 90% confidence level and Lisa is going to use an 85% confidence level. So the question is, which confidence level, 85% or 90%, is going to result in a larger margin of error? So if we go back to what we talked about on the second page, talking about confidence level, larger error comes from a larger confidence level. Okay, so larger confidence level. Larger confidence level would be the 90%. Which was Michael's. Part B. Which confidence interval is more likely to contain the true population mean? Or are they both equally likely to do so? Remember when we talked about the interpretation of the confidence level in the last lecture, right? The confidence level is how likely you are to catch the true population mean or proportion. So a higher confidence level, you are more likely to catch the true population mean. So I want the higher confidence level, which would be the 90% again, which was Michael's. So the moral of the story is, larger confidence level means you are more likely to catch the true population mean or proportion. So in general, you want a higher confidence level. But the downside of a higher confidence level is that you also have a larger error, which you don't want, right? So what do? You can compensate for it by picking a larger sample size, because a larger sample size will reduce the error. All right, that's it for confidence intervals. Have a great day. See you next time.